Hey there, space enthusiasts! Today, we've got some mind-blowing news from our cosmic neighborhood. Neptune, that icy, faraway planet, just threw us a cosmic curveball. New pictures from space telescopes have caught something super strange happening there. Seriously, it's like Neptune is playing hide and seek. But before we dive into this cosmic mystery, make sure to hit that subscribe button and give us a thumbs up, because you don't want to miss out on any of the incredible space discoveries we share here. So let's join forces to unlock the secrets of our universe together! Now, back to Neptune's Enigma. Astronomers have stumbled upon something truly bizarre unfolding in the distant realm of Neptune. You see, this isn't your usual cosmic story. It's like Neptune decided to shed its cloudy attire. Normally, Neptune's atmosphere sports a beautiful blue hue, but it's a lively and ever-changing place, unlike our serene Earth skies. With some of the speediest winds in our solar system whipping around at up to a staggering 2,000 kilometers per hour, that's about 1,200 miles per hour. It's a real cosmic whirlwind. These winds usually send clouds of methane and other gases swirling about in an endless dance, but here's the twist. Recently, all these clouds have mysteriously vanished from Neptune's atmosphere. It's as if the planet's undergone a cosmic makeover, leaving it nearly cloudless and dramatically altering its appearance. Hold on to your space helmets, because we're about to delve deeper into this astonishing celestial enigma. And don't forget to hit that subscribe button, because we've got more cosmic secrets to unveil. The plot thickened when scientists uncovered the underlying cause behind this celestial transformation. You won't believe it, the enigmatic culprit behind Neptune's cloudy vanishing act is none other than the 11-year solar cycle. It's a solar phenomenon that still leaves us scratching our heads. Now, let's get on to the exciting part. How did astronomers even figure this out? I mean, we're talking about the Sun, which sits a staggeringly 4.4 billion kilometers away. How could something so distant have such a colossal impact on Neptune's atmosphere? And here's the kicker. What evidence do we have to back up this jaw-dropping idea? I mean, Neptune is like the dark horse of our solar system, the least explored planet. The Lone Ranger that visited it was Voyager 2 in its historic 1989 flyby. That journey unraveled Neptune's striking and enigmatic atmosphere. Stick around, because we're about to reveal all the mind-blowing details. And if you want to stay updated on these cosmic discoveries, don't forget to hit that subscribe button. The spacecraft's keen observations unveiled a Neptune like no other. Its atmosphere, a tempestuous realm of formidable winds and captivating cloud formations, kept the scientists on the edge of their seats. What's more, this icy giant's atmosphere was a complex puzzle comprised of multiple layers. At the very top, we have the troposphere. That's where the show begins, with those mesmerizing clouds forming right before our eyes. But brace yourselves for the most breathtaking revelation of all, the Great Dark Spot. It's akin to the legendary Great Red Spot on Jupiter, but with a unique Neptunian twist. Voyager 2 laid bare the sheer grandeur of Neptune's Great Dark Spot, a colossal storm system that could easily swallow our entire planet whole. Now that's a celestial spectacle for the ages. Stay tuned as we delve deeper into this cosmic wonder, and if you're as awestruck as we are, don't forget to subscribe for some more mind-boggling space stories. However, when the Hubble Space Telescope turned its gaze towards Neptune in the 1990s, something remarkable had occurred. The once prominent storm had mysteriously vanished. This unexpected disappearance served as the first clue that Neptune's atmospheric elements were undergoing significant transformations, leaving scientists intrigued. Voyager 2, during its remarkable 5-month study of Neptune, unearthed another pivotal discovery: the precise chemical makeup of its atmosphere. Extensive analysis revealed the prominent cloud formations were primarily composed of hydrogen, helium, and methane. Now here's the fascinating part. Neptune's upper atmosphere has a special penchant for absorbing red light from the sun. Consequently, the only light that manages to escape and reach us is blue, bestowing Neptune with its characteristic bluish hue. While Voyager 2 proved to be an invaluable resource, providing us with a treasure trove of information about this ice giant, it's important to note that due to the sheer distance, engineering challenges, and prohibitive costs involved, no spacecraft has ventured to visit Neptune since Voyager 2's historic mission. However, this didn't mean we gave up on exploring the far-flung reaches of our universe. In fact, since Voyager 2's mission, Neptune has continued to capture our attention. Powerful space telescopes such as the Hubble Space Telescope have enabled astronomers to periodically observe Neptune. These observations have allowed scientists to track changes in Neptune's cloud patterns and even identify new features. Additionally, ground-based observatories equipped with adaptive optics have provided high-resolution images of Neptune's sphere, revealing intricate details of its cloud formations. However, the cloud cover over Neptune is far from static. It continually evolves, and over the years, the clouds have nearly disappeared. To closely monitor this phenomenon, researchers conducted a detailed examination of the cloud cover's time variation over the last 3 decades. They delved into the infrared data collected by instruments like the Hubble Space Telescope, the Keck Observatory, and the Lick Observatory between 1994 and 2022. What they uncovered was truly astonishing. Located a staggering 4.4 billion kilometers from the Sun, Neptune receives a mere 0.1% of the sunlight that our planet enjoys. Naturally, one might assume that with such a meager amount of sunlight reaching Neptune, just 0.1% of what our planet receives, the Sun would play an insignificant role in Neptune's atmospheric dynamics. But when scientists meticulously examined the images of Neptune captured by various telescopes over the past 29 years, they unearthed remarkable correlations between seasonal shifts in Neptune's cloud cover and the solar cycle. This revelation suggests that, despite its vast distance from the Sun, Neptune remains under the subtle influence of our star. Here are some images captured by the Keck Observatory and the Hubble Space Telescope between 2002 and 2020, which were specifically employed in this study. Notably, after 2020, there was a conspicuous decline in cloud activity, particularly in the mid-latitudes. For instance, since 2019, scientists have observed only a single patch of wispy white clouds drifting around the planet's south pole. Even now, after 4 years, the clouds have not returned to their previous levels. Neptune is experiencing a nearly unprecedented phenomenon. It is nearly devoid of clouds, a phenomenon not witnessed in 3 decades. Now the question that arises is, how exactly does the Sun factor into this intricate interplay? To grasp this connection, it is crucial to acquaint ourselves with the concept of the solar cycle. Much like human experiences of surging energy and periods of profound fatigue, the Sun also goes through ebbs and flows in its energy output. These oscillations manifest as periods of heightened activity marked by the appearance of abundant sunspots and energetic outbursts, followed by quieter phases. This rhythmic modulation of the Sun's energy emissions is what we refer to as a solar cycle. Think of it as the Sun's way of adjusting its vitality levels. Typically, a solar cycle spans approximately 11 years, during which the Sun exhibits varying behaviors. During the phases of solar turbulence, when the Sun is at its most active, the solar system experiences an influx of more intense ultraviolet radiation. Solar cycles are an inherent feature of the Sun's behavior, and they exert a profound influence on space weather, impacting Earth's magnetosphere and communicating systems. In a recent study, scientists tracked the past 2.5 cycles of solar activity, characterized by solar maxima in 2002 and 2015, and minima in 1996, 2007, and 2020. They aimed to discern the relationship between these solar cycles and Neptune's cloud formations. This investigation revealed a noteworthy pattern. The appearance of clouds on Neptune tends to commence approximately 2 years after the onset of intense ultraviolet radiation. Furthermore, a significant correlation was uncovered between Neptune's cloud cover and its albedo, which measures the amount of sunlight a planet reflects. The planet's cloud cover and albedo experienced a peak in 2002, followed by a decline in 2007. Subsequently, they surged once more to a peak in 2015 before subsiding again. Remarkably, these timing patterns align precisely with the two most recent solar activity maxima, occurring in 2001 and 2015, thereby establishing a clear and compelling correlation between these two phenomena. One plausible explanation for this intriguing phenomenon is the hypothesis that the sun's intense ultraviolet radiation triggers a complex photochemical reaction leading to the formation of Neptune's clouds. However, it's important to note that this relationship is intricate. For instance, an increase in UV sunlight could enhance the photolysis of methane gas, consequently promoting the production of hydrocarbons and associated hazes. Conversely, a surge in UV radiation might also lead to a darkening of aerosols and hazes, ultimately diminishing Neptune's overall brightness. Nonetheless, it's important to emphasize that we've thus far observed a positive correlation between solar activity, cloud cover, and the planet's brightness. This strongly suggests that Neptune's internal processes could also play a pivotal role in influencing these behaviors. This implication raises the possibility that the Sun may not be the sole driving factor behind these phenomena. Ongoing observations are being conducted, and researchers have acquired new data from the James Webb Space Telescope that corroborates the team's findings. Nevertheless, it is imperative to underscore that continued observations of Neptune are essential to reach a definitive and concrete conclusion regarding these intriguing dynamics. In closing, these intriguing new images have unveiled Neptune's mysteries. The interplay of solar activity, cloud cover, and planetary brightness leaves us with more questions. Science continues to unravel these secrets, deepening our understanding of our celestial neighbors. Stay tuned for further updates on Neptune's ever-changing landscape. Subscribe for the latest cosmic discoveries, and thank you for joining us on this journey. Until next time, keep exploring the cosmos.